Today we're going to take a look at misleading data. So the first thing I want us to do is take a look at these graphs. We're going to skip the video for right now. What do you notice about these graphs? Well, I notice the year is the same, but the scale is different. And so how does that make us perceive these graphs? For example, B looks like it's increasing more rapidly because that's a steeper line, and just because of the scaling. So if it asks us which graph might the student council use to show that prices have risen, the increase is not that significant, I would definitely choose graph A. It's going up, but it doesn't look nearly as steep as that graph B. So if we take a look at these next ones, again, scaling is huge. So when you look at this first graph, it looks like the snowfall is really different, but not so much the second graph. And again, if you look at the scale, what this is saying right there, that squiggly line, is that we're missing some values there. That little dash means we're jumping right up to 14. Where if you had it to scale, you can see that it's really not that different. So this is kind of a practice not starting a graph at 0. So let's take a look at this next one. The president of a large company mailed a survey to 500 of his employees in order to determine if they use the fitness room at work. The results are shown in the graph. Identify any sampling errors and explain why the sample in the display might be biased. Well, let's see. I think about just being mailed. Do they even get everything returned? Let's see. 500. So how many did he get back? 338, 116, 4, carry the 1, 3, 4, 5. So you got 454 back. So he's missing some people. So it's voluntary. We don't even know for sure. We could have another 50 people here, which would boost that one up to a no. So that's another one called biased samples. We're not really sampling everybody. Number 4, marketing research. So if we take a look at this table on roller coasters, it wants to boost the average, say that the average height is 170. So if we take a look at that, sure, the average is 170, but really this one's at 365 and everything's way less. So we have one roller coaster that's bumping it out of average. So we need to make sure that even though that's true, is that a good representation? In this case, the median might be better because that's in the middle. So we have to make sure we're using a good statistic to model our data. So these are all different practices that can be considered deceptive. Graphing the intervals, not starting at 0, not using all the data, and using the wrong measure of center, especially if one of them is an outlier. So let's see, what's misleading about this graph? Democrats, Republicans, and Independents. It almost looks double. Well, we're not starting at 0. How about this next one? The percents who agree with the court. So again, it's not necessarily wrong, but the graph interval could be changed because this looks like 54 and 62 are super close. But we could make it look a little bit further apart if we changed our graph interval. If we take a look at this next one, what's misleading about this? Well, again, it's our scale. There's a huge difference when we're counting by 5s versus by 10.